Let's see what we've got. We make it foo. We make sure everything's nice and clean. Make it clean. Directory. Make it foo. Okay, everything's happy. We make sure that we're looking at the right thing over here. Okay, where's your folder that should be in Strupper? Yeah. So we'll put that one over here to go with it. Here's our source code files. Strupper asm. Okay. When we make it over here, make it clean, this guy's going to suddenly get real clean and everything's gone. We go to make it foo, it gets all dirty, but those things have value. Now, asm brings this up, list probably doesn't, and map probably doesn't, but there's two files there, one called foo map or something map, and strupper list. Drag those to your editor. They're of use in the debugger. Looking at them, the list is what the compiler sees when it generates your program. It literally is, here's your source code off to the side, here's the generated machine code. Edit input, a bunch of blanks, 20, 20, 20, 20. 20 hex is 32 decimal, that's the ASCII code for a space. And at the very end of it, there's a 13 and a 10, 0D and a 0A. And there's a $, that's a 24. Down in code, what do we see? We actually see the machine language in hexadecimal, the ones and zeros. 8CD8 is move AXDS, and that's at address 10. Startup must be taking up 10 hexadecimal bytes. All of these addresses are in hexadecimal. So the column at the far left in your listing file is the addresses. That's really important. Why? Because what do you want to do? If you want to debug a program, you've got to have location, location, location. Where's data? Where's code? Exactly where. Okay? Exactly where. You've got to know their addresses. So particularly with code, you start and find it. Notice, .code, address 0. Main, still address 0. .startup doesn't have anything on it, it's hiding it from you, but the very first instruction we typed has address 10. Now we can come over here and we want to say symdeb. That's the name of the symbolic debugger, foo.exe, and you have to be explicit and give it the right name. If it takes parameters, A, B, C, D, E, F, or anything, you can add them there, but this doesn't, we don't need anything extra. Symdeb foo.exe, it should not give you an error. If you forget to type exe, it'll come up and say file not found. Symdeb foo.asm, it'll be real happy, whoops, quit. Symdeb, strupper.asm, it'll be real happy, except it won't be code, it will be your source code. Dump at CS100. It's literally your source code. Don't debug source code. You debug the executable code. Symdeb foo.exe. Got it? In Symdeb, question mark, and I did this on screen, gives you a big help screen. But the key things that you should know are the following. When you're sitting editing code, you should be going Alt-Fs, 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 then type some Alt-Fs. There's a twitch that you do when you're on a keyboard. Got it? While your brain is thinking about other things, you have a twitch. In an editor, saving the file. In the IDE for Java or something else, in the IDE for Java or something else, compile, compile, compile. In a debugger, you want context. R is your #1 command. R shows you all the registers and the current values. AX is 0, BX 0, CX 1DA, and a bunch of other things. These are the flags. That says no overflow. That says we're going up with the string instructions versus DN for down. PL for plus, I think. Yeah, plus, as opposed to NG for negative. NZ for non-zero. NA, forget that one. And PO, forget that one, it's just pissed off. and then NC for no carry. Okay, CY for carry, no carry. All right, where are we? That's what the first part of each of the third line is. The very first thing is 4:4, hexadecimal address in segment offset form. The first one is the segment. Code segment 35A6, CS35A6, IP address 0, 35A6, 0. That's the machine language, and that's the actual assembly language. Where is that in our list file? Well, we're at address 0, so it must be in what .startup is. That's what it is. But at address 10 in our list file, should say DS moved into AX. The next most useful command, unassemble, add an address. Move DS AX, move DS AX, move AX to ES. And you look at it and you're verifying to make sure that the addresses are what you think. Got it? You're gaining context on where things are. It's just like Google Map. You're trying to figure out where something is exactly. Okay, maybe it's not Google Map, maybe it's more like orienteering in Iraq. Okay, you literally have GPS coordinates and you have to get them exact. If they're not exact, you're in the wrong place, and that's a bad thing, isn't it? Yes. Okay, so it matches, we're good. Now, tell us the problem, again.
The printing.
The
After
printing.
the second loop.
So, let's back up to our source file. Tell me in the second loop, show me where you're talking about. Show me the code that you think is where the problem first occurs.
It prints out properly going down.
Show me the first place where you print it out. Let's start there. I don't know, I take that back. I'm going to do this easy way. I'm going to walk through your code. Here we go. Top of your loop. The top of his loop starts with move AH9, move offset prompt to DX, and int 21. Print the prompt, right? Find that in the list file. That's at address 14. Now, if R gives you context, you keep twitching. Remember where you're at. I know where I'm at. I want to stop at address 14. That's where I want to start debugging. And that's your next important command, G. If you just say G, it's going to go and run forever and do its normal stuff. If it exits properly, it'll exit. But we want to go and stop. We want to get to where we can execute one instruction at a time. So we want to stop at either the very first instruction or the very first one of interest to us. Just by I've learned that 99.9999999% of the time, .startup is exactly 10 hexadecimal bytes. So go 10, G10, always gets me to the first instruction I've actually coded. Move DS AX. Here, we're going to go through and we're going to see if everything works. That's your next important instruction. T. Trace the current instruction. We're on move DS AX. Look at AX right now. They happen to be exactly the same thing. Will there be any effect? Shouldn't be. Trace. Nope. Move ES AX. ES and AX are different, and we should see it actually change. Trace. And it does R every time after you hit trace. T executes the current instruction that's shown, then shows you the new registers and the new next instruction. This should give you hints. It's literally showing you where the processor is going to execute the next instruction. Make sense? So, G to go, R to get context and show you everything, and you just do R all the time. And U to show you the stuff that comes after it. R and U together is my little twitch. RU, RU, RU. Can't do them together though, too bad. Other debuggers you can. You can say R and like that. Ooh. Oh, wow. Holy crap, Batman. No, that can't be it. That can't be right. There's no way that this old version does that. R, U, R, G, 14. Holy crap. They did. Wow. How they fixed that in this older version, I don't know. You can combine commands. Unbelievable. Input a string. A, B, C. I don't want to. I want to start it over. You start over a lot in the debugger. A lot. You get to a point where if you've lost context, you start over. Just use the up arrow. Now you start remembering things. Go and stop at 10. Unassemble. Are you? Oh, are you? Oh, God, that's great. I'm going to have to... If I'd only known that 30 years ago. Here's where we are. We're going to execute it. It's going to actually print the prompt. Okay. What do we have? Well, follow it in the list file. What do we want? It's going to do the prompt. We know the prompt's printing out pretty nicely, so we're probably not interested in that. What's the part that's interesting? The input buffer. Move 0 to the actual string length, move 0A to AH, offset of max string length into DX. Okay, that's the input buffer, which is 3 parts for AH equals 0, yeah? Okay, and then in 21. That's probably pretty interesting. So that's at address 1B. Find it, unassemble at 1B, make sure it looks like it. Move byte pointer 0003 0. Move 0 to something in memory at address 3. Move a byte 0 to address 3. So actsterlen is address 3. Now, if you have them public, which you don't, it will actually show you addresses over here for certain things. Like, in his case, do lower, do upper, and this is all code. I'm going to show you a interesting trick, and we'll, again, exit here, come back over and redo in his work. Everybody look closely. Go to your data segment. What are the pieces of data you might want to look at over and over? Well, you're going to want to look at the user input. You're going to want to look at the edited input probably, yeah? The word is public, not oibaigic. Public, there we go. And you can make them all public. It's happy with that. Actsterlen user input. Edit input. Prompt. And exit. Not a good word to use. Probably not a good word. Exit, size, data. Too many chances that it conflicts with an existing reserved word. Got it? If you will turn around, I'm going to make that one, there we go. If you'll make them public, if you'll add this line to your data segment with the variables that you define, save it. Oh crap, I have to take this.
That's what they need interns.